rational functions can be a tricky part of learning algebra, but they are very important and they will show up a lot in calculus. So we are going to do 3 different examples. The first one here is f of x is equal to x squared plus x minus 12 over x squared minus 4. So the first thing you always want to do is you want to factor the top and the bottom if possible. So the top is going to factor 2, x plus 4 times x minus 3, and the bottom is a difference of squares, x minus 2 times x plus 2. Please always make sure that you check your factorization. You need to FOIL out because if your factoring is incorrect, the rest will also be incorrect. So the domain here is going to be all real numbers except what makes the denominator 0. So it means that x cannot be negative 2 or 2. Now the y-intercept, remember, is when x is 0. So when I plug in 0 into x, everything will turn 0 except for the negative 12 in the top and the negative 4 at the bottom. So it will give me a positive 3. So I will have the point 0, 3. Now the x-intercept is when you take your function and y is 0. So that y is f of x. So you set this all equal to 0. Now I'm going to bring this over here. So anything times 0 is 0. So I'm going to be left with x plus 4 times x minus 3 is equal to 0, which gives me that x is negative 4 and x is positive 3. So I have 2 x-intercept, one at negative 4 and one at 3, 0. Okay, your vertical asymptotes and your holes, they go together because remember, everything in your domain that does not exist, that is undefined, will either be a vertical asymptote or it will be a hole. And it won't ever be the same, a vertical asymptote and a hole at the same time. Okay, so a hole will happen if the factor in the denominator cancels with a factor in the numerator and is no longer in the denominator. In this case, that doesn't happen. Every factor in the denominator doesn't cancel, so you have 2 vertical asymptotes, one at negative 2 and one at positive 2. Now, your horizontal or your slant also go together because if you have a horizontal, you will not have a slant and vice versa. Because a slant asymptote happens when the degree of the numerator is more than the bottom, and in this case, you have no horizontal asymptote. Here, actually, our degrees are the same. The degree of the top is 2, the degree of the bottom is 2. So in the situation where they are the same degree, you take the leading coefficient. That is the coefficient that is with the highest power. So the leading coefficient of the top is 1, the leading coefficient of the bottom is 1. 1 divided by 1 is 1. Now, keep in mind that a vertical asymptote happens where your domain is undefined. So your vertical asymptotes and your holes do not exist. The graph can never touch those. However, a horizontal or a slant asymptote can be crossed by your function. And so what we do next here is we figure out, is that going to happen? So what you do is you take your function f of x and you set it equal to your horizontal or your slant asymptote. Because intersection means that they are equal at some point or points. So my function is, and this is actually easier to do in the unfactored form. It's a little trick. And you set it equal to whatever you found as your horizontal or your slant, and we found that it's 1. And then you try to solve for this. So I'm going to bring this over here. It's going to give me x squared plus x minus 12. Anything times 1 just gives you back what you started with. The x squares are going to cancel out, and I'm going to get x is equal to 8. So you do have a cross, and it's going to happen at x is equal to 8. Now your sign chart is you're going to figure out what sign your y's take. Are your y's positive or are your y's negative? To create your sign chart, you take your x-intercepts, your vertical asymptote, and your holes. So I had 2 x-intercept. I had one at negative 4 and 3, and I had 2 vertical asymptotes at negative 2 and 2. And so you put those in increasing order. So negative 4 will come first, then negative 2, then positive 2, and then 3, and then infinity is here. And you draw lines from those numbers. And then you pick test points in between each of those intervals, because that's where the sign can change. An x-intercept is where you cross or touch the x-axis, so a sign can change from positive to negative. And on the left of the vertical asymptote, you can be below the x-axis, but on the right, you can be above. So you want to figure out what's happening here. So for example, you pick negative 5. Now you want to look at the factored version of f of x. So let's write this here. So it was x plus 4 times x minus 3 over x minus 2 times x plus 2. And you're going to plug in -5 in here, and you don't want to know the number, you just want to know the sign. So you plug it into each factor. So -5 plus 4 is a negative number. -5 minus 3 is a negative number. So a negative times a negative gives me a positive in the numerator. -5 minus 2 is a negative number. -5 plus 2 is a negative number. So a negative times a negative gives me a positive in the denominator. And the positive divided by a positive is also a positive. All right, next interval, -3. Okay, so a -3 plus 4 is positive. A -3 minus 3 is negative. So it's a negative in the top. -3 minus 2 is negative. -3 plus 2 is a negative. So that's a positive in the bottom. So it gives me a negative. 0, well, we already did 0. That was the y-intercept. So I give us a positive 3. Between 2 and 3, we're going to do 2.5. So 2.5 plus 4 is positive. 2.5 minus 3 is a negative. 2.5 minus 2 is positive. 2.5 plus 2 is positive. So that's a positive. So the fraction is negative. And then if you plug in 4, everything will be positive. So this is positive. All right, let's put together our graph. So the first thing we want to draw is we want to draw our asymptotes. So let's do that first. So let's do at -2 and 2, the vertical ones. And we had a horizontal one at 1. And then we're going to plot our x and y-intercept. So we had a y at 3. I believe it was -4 and +3. So we have one at -4 and +3. And we're going to have a cross of our horizontal asymptote at x equal to 8. So that's over here. Okay, so now we look at our sign chart. So from the interval from -infinity to -4, I am above the x-axis, and I need to run along my horizontal asymptote. So it's going to look like this. I'm above the x-axis and running along my asymptote. From -4 to -2, I am below, and I need to run along my vertical asymptote like a river. From -2 to 2, everything's above, and I obviously need to also go through my y-intercept. So on the left, I run along this asymptote, and on the right, I run along this asymptote. From 2 to 3, I am below, and I need to run along my vertical asymptote. And from 3 to infinity, I am above, and I need to cross my asymptote, but I need to come back and run along it. Okay, because remember here, the asymptote keeps going. So you want to imagine that you're getting closer and closer and closer to it. Okay, so here is example number 1. Let's do another one. Okay, so the first step here is going to be to factor. So the top is a 4-term polynomial, so we're going to try by factoring by grouping. So I'll group the first 2 terms together and factor out an x squared. That'll leave me with 2x plus 1. And I'll group the last 2 terms together, and I'll factor out a -4. And that will leave me with 2x plus 1. So factoring by grouping works because I have the same factor. So I can now factor that out, 2x plus 1, and be left with x squared minus 4. But x squared minus 4 factors even more. It factors 2, we already did it in the previous problem, x plus 2 times x minus 2. Now the bottom is going to be a little bit easier to factor because it's just a trinomial. And it's going to factor to x minus 2 times x minus 1. And then again here, check your factorization. So as you can see, there is a common factor in the top and the bottom, but we're going to talk about that in a little bit. First, you take your domain without canceling anything. So it's going to be all real numbers except what makes the bottom 0, which is 1 and 2. Your y-intercept is f of 0. Do this in the unfactored form. So everything will turn 0 except for -4 over +2, which will give me a -2. So the point will be 0, -2. Then the x-intercept is so here the x-intercept is, now you want to cancel. You want to cancel the common factors. So when I cancel the common factors, it's the x minus 2. The reason for this is because now you want to take out the parts, because when you do the x-intercept, you're going to set everything equal to 0 to find where the x-axis is going to cross. But you can't have anything that's undefined because the graph doesn't exist there. So when you have 2x plus 1 over x plus 2 over x minus 1 is equal to 0, you will bring this over here, and then you'll set the top equal to 0, and so you'll get x is equal to negative 1/2 and x is equal to negative 2. If you forget to take your x-intercept before you cancel, you would have gotten x is equal to 2, but x can't be 2 from the domain, so then you would have to take that one out. So it's okay if you don't cancel, just remember to always look at your domain. Okay, your vertical asymptote and your holes. So because x minus 2 cancels with the top and it's no longer in the denominator, x is equal to 2 is a hole, and x is equal to 1, because it didn't cancel, is a vertical asymptote. Now to figure out exactly where the hole is, you plug in 2 into the simplified version. So it's going to give me 2 times 2 plus 1, 2 plus 2 over 2 minus 1. So 2 times 2 plus 1 is 5, 5 times 4 is 20, over 1 is 20. So my hole is at 2, 20. Okay, now let's look at our horizontal or our slant. So the degree of the top is 3, the degree of the bottom is 2. So because it's exactly one more than the top is one more than the bottom, it is a slant asymptote. Now the key here, the trick here, is you can actually find the slant asymptote from the simplified version. So you can use f of x is equal to, and I'll FOIL this out the top. It's going to give me 2x squared plus 5x plus 2 over x minus 1. The reason that I'm going to use this version is because in this version I can use synthetic division. And in the non-simplified version, I have to use long division. But synthetic is easier. So this is a little bit of a trick here. You can use it from the part after you canceled the common factors. So when I use synthetic, I will have to use 1, 2, 5, 2. Bring down the 2. 2 times 1 is 2. This is 7. And here I don't care because my slant asymptote is the quotient. Okay, now I want to figure out if this slant asymptote is going to cross with my graph. And then again, here you can use the simplified version. So again, you're using the simplified version everywhere except for the domain and the y-intercept. So here we have the 2x squared plus 5x plus 2 over x minus 1 is equal to my slant asymptote of 2x plus 7. So I need to bring this over here. I need a little bit more space. So that's going to give me 2x squared plus 5x plus 2. I'm going to FOIL that out, which is going to give me 2x squared plus 7x minus 2x minus 7. The 2x squared cancels. I have 5x plus 2. 7x minus 2x is 5x minus 7. The 5x cancels, and I get 2 is equal to negative 7. Well, that's never true. So that's a contradiction. So you have no intersection. Your slant asymptote and your graph will never intersect. Let's create our sign chart. So I need to take my x-intercepts, which I forgot what they were, negative 1/2 and negative 2. I need to take my vertical asymptote and my hole. So let's write that in increasing order. So I have negative infinity, negative 2 comes next, negative 1/2, 1, 2, infinity. You don't need to write the negative infinity and infinity. I'm just doing it as a reminder that they are there. So when you pick your intervals. So here I'll pick negative 3, here I'll pick negative 1, here I'll pick 0, here I'll pick 1.5, and here I will pick 3. And again, you can use the simplified version, but here you want to use the factored form because remember, you're not looking for it with the number, you're looking for where it's positive or negative, and it's easier to do that from the factored form. Okay. So let's plug it in. Let me make sure I have it right. 2x plus 1, perfect. So if we plug in negative 3, I'll have a negative times a negative, which will give me a positive, divided by a negative. When I plug in negative 1, that will give me a negative times a positive over a negative, so that will give me plus. 0 we already did. That was the y-intercept, which was a -2. So that was negative. 1.5, so 2 times 1.5 is 3. So it will be a positive times a positive. So positive at the top. 1.5 minus 1 is a positive. And when I plug in 3, I will get a positive times a positive divided by a positive. Everything is positive, so that's a positive. All right, now you get to put everything together. It's like a puzzle. Put all your pieces together. So let's see. First, we're going to graph our asymptotes. So I had an asymptote at x equals to 1 and then 2x minus 7. So obviously x is equal to 1 is going to be the faster one of doing. And then you're going to have 2x plus 7. So 7 is right here, and then your slope is 2. So up 2 over 1, 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 and do as many as you want to really get that straight line. And then you can also go down 2 over 1, down 2 over 1, down 2 over 1, down 2, 1, 2, and so on. Really want to create a straight line, right? So doesn't take that long to do the slope. Okay, and these will never be touched, never be crossed, because we found that out above. Now we need to plug in our x-intercepts. So that was -1/2 and -2. Oops. So -2 and -1/2. And then we had an x-intercept, a y-intercept, I'm sorry, and -2 also. And then you look at your sign chart. So from -infinity to -2, I am below the x-axis, and I need to run along my asymptote. From -2 to -1, I am above. It's a positive. So -2 to -1/2, sorry, I'm above. So I'm going to connect those 2 points above the x-axis. Then from -1/2 to +1, so to the vertical asymptote, I am below, which makes sense because I need to connect to my y-intercept and I need to run along my asymptote. Okay? Now remember that on the right here I have a hole. My hole is at 2, and we found out exactly where it was. It was at 2, 20. So let's plot it. Don't forget about it. So it's right here. And everything from 1 to 2 and then 2 to infinity, I am above the x-axis, and I need to run along my asymptotes. So to the left of the hole, I will be above and run along my vertical asymptote, and to the right of my hole, I will run along my slant asymptote. And here's your final graph. Let's do one more. So the first step is to factor. So let's do it in black. So we have 2x times x, 1 and 1, and then I need a +2 and a -1. And then the bottom here, I can factor out an x, and I think that's the only thing I can do. So my domain is going to be all real numbers, except x cannot be -4 or 0. My y-intercept, when I plug in f of 0, I get -1 over 0, which is undefined. And we know this because we just said x couldn't be 0. So you have no y-intercept, which can happen. Okay, your x-intercept is so here take note that nothing cancels, right? There is no common factors. So this is as simplified as it is. This comes here. And when you do that, it will give you x is equal to 1/2 and x is equal to -1. So I have -1, 0, and 1/2, 0. Okay, since nothing cancel, everywhere my graph is undefined is a vertical asymptote. So 1 at -4 and 1 at 0. Always remember to write your asymptotes as equations. The degree of the top is the same as the degree of the bottom. So it's going to be the leading coefficients. So I have the leading coefficient of the top is 2. The leading coefficient of the bottom is 1. So I have a horizontal asymptote at y is equal to 2. Now I want to figure out if that intersects with my graph. So I take my function 2x squared plus x minus 1 over x squared plus 4x. And I set this equal to my horizontal or my slant asymptote. I bring this over. It's going to give me 2x squared plus x minus 1 is equal to 2x squared plus 8x. These cancels. I have negative 1 is equal to 7x, which means that x is equal to negative 1/7. So it's a tiny little x, but it's still crossing. I still solve for it. So now we need to create our sign chart. So I have negative infinity, I have my x-intercepts and my vertical asymptote. So I had a vertical asymptote at negative 4, an x-intercept at negative 1, a vertical asymptote at 0, and another x-intercept at 1/2. I draw numbers, lines, not numbers. I pick test points, so negative 5, negative 2, negative 1/2, 1/4, and 1. And you want to do this from your factored form. So f of x is equal to 2x plus 1 times x. Oops, I think it was minus 1. It was minus 1, so this is a minus here. That's important. Over x times x plus 4. Okay, so when I plug in a negative 5, I'll have a negative times a negative, it's positive, over a negative times a negative, so that's a positive, so everything is positive. When I plug in negative 2, that will give me a negative times a negative, over a negative times a positive, so that will be a negative. Negative 1/2 will give me a negative 1 minus 1, which will be a negative. Negative 1/2 plus 1 is positive, though, so that will be a negative, over negative 1/2 times negative 1/2 plus 4, which is negative. So this will be positive. 1/4, so 2 times 1/4 is 1/2. 1/2 minus 1 is a negative number. 1/4 plus 1 is positive, so this will be negative. 1/4 times 1/4 plus 4, everything is positive at the bottom. And when I plug in 1, everything will be positive. And then you put all your pieces together. So first, let's draw the vertical asymptote and the horizontal asymptote. So I have one at negative 4. And one at 0. And I have a horizontal one at 2. Okay. I have an x-intercept at negative 1 and 1/2. So negative 1 and 1/2. And my horizontal asymptote will cross at negative 1/7. So let me zoom in, right? That would be like negative 1/7 would be like right here. Yeah, you can approximate. It's close to 0. And then I have a y-intercept at, believe it was at, no y-intercept. That's right. There's a vertical asymptote there. It can't exist at x equals 0. Okay, and then we look at our sign chart. So from negative infinity to negative 4, I have to be above the x-axis and I need to run along my asymptote. So the only way that's going to happen is if it's like this. It can't be below because then I would cross the x-axis and be negative. From negative 4 to negative 1, I am below and I need to run along my vertical asymptote. From negative 1 to 0, I am above, which makes sense because I'm here and I'm going to cross my horizontal and keep going above. From 0 to 1/2, I am below and I'm running along. And then from 1/2 to infinity, I am above and I cannot cross my horizontal asymptote again. So I just run along it and get closer and closer and closer to it. And here is the final graph.